So suppose you had a function, as presented, and you were trying to figure out what value of x would have this function return 3 as an answer. So this is exactly backwards to what your BEDMAS stuff is. Instead of being given the input and asked to find the output, here I've been handed the output and asked what values would cause that to occur. So algebra really is just order of operations backwards. So if we were to follow those same 3 rules that we had before, which were 1, evaluate the arguments, 2, execute function, and 3, external stuff, we just have to undo all these steps. And if we can undo them in the correct order, then we'll have returned the input that gave us 3 as the output. So the first thing you have to do is imagine that there is an answer. So let's start with that. Let's start with x. With x. Okay. Now, if you started with that x there, if I knew what it was, so let's say it's 10, the next thing you do according to order of operations is once you had that x, you would add 4, which would give you x plus 4, whatever that number is plus 4. The next thing you'd had to do would be multiply by 2, which would give you 2x plus 4. At that point, you would have finished evaluating the argument, so it would be time to execute the function. So execute square root. Wow, that's not even close to the word execute. Execute square root. Should have given you this. Once you'd executed the square root, we start applying the external stuff, which means you would have had to multiply by 3, giving you this. And then finally, you would have subtracted 12, which would have given you this full thing, which we've recently been told is worth 3. Okay. So, if you can take a minute to appreciate what's happened, if I know what the input is, order of operations gives me a list of things to do in order to crank out an output. So if I have the output instead, I just have to go back through these steps and undo each of them. So if I were to do that, instead of starting with x, if I started with this number, what I want f of x to equal, and I start undoing these steps. Take 3 and undo subtracting 12. Well, if you undo subtracting 12, that's addition. So 3 plus 12 would give me 15. Okay. Now that I have this step done, I have to undo this one. Undoing multiplication requires division. So I'm going to have to take my answer from the last step and divide it by 3, which gives me 5. So that step is done. Now I have to undo an execution of square root. So this is the only step that is different for different functions. You're going to have to remember how you undo a square root. And of course, in this example, it's squaring. I'm going to make a little note there. What you did there was you summoned the anti-function. So square root and square are a special pairing because they undo each other. So when you get to this level, or sort of the step in the problem, when you have to undo the radical, you need to summon its antifunction pairs, which is squaring. If this thing had been square, then you would pull a square root here. If this was cube, you would use cubed root. If this is cubed root, this would be cubed. So every function has a way of undoing some other function. So you're going to need to make a list of those things. We're going to go through, we're going to finish this radical example. So you'll see that the antifunction for a radical is squaring. We're going to do a ln, so you can see its antifunction. We're going to do an e to the x, and we're going to do a rational expression so that you'll get all those antifunctions written down. Anyway, 25, or 5 squared is 25. Now I have to undo this multiplication by 2, which requires me to divide by 2, which is 12 and a half. I have to undo adding 4, so 12 and a half subtract 4 gives me 8.5. And that's it. That's the input that should render an answer of 3. Now, you probably haven't seen it done this way before. So I'm going to erase it in a minute, and we'll run through it the way you've normally seen this done. But I want to check this number first. So let's run it through these steps. 8.5 plus 4 would be 12 and a half. 12 and a half times 2 would be 25. The square root of 25 is 5. 5 times 3 is 15, and 15 subtract 12 is 3. So by reversing these steps, you were able to reverse engineer the input from the output you receive from that function. And that's the entire point of algebra, is to be able to work backwards through the steps in order to figure out what number went in to have this number come out. So if I clean this off for you, and then we will try this in the more traditional fashion, leaving 8.5 up there. What you've probably seen before is you take the function and you set it equal to that number. You pull this over to the other side. If it's a negative on this side, it's adding on that side. So 3 plus 12 equals 3. 2x plus 4. 3 and 12 is 15. That's a familiar number. That crept up in the way I had it done before. Right, divide both sides by 3, gives you 5. In order to break a square, you have to square root both sides because you are summoning the antifunction. Square 5, you get 25. Don't forget your brackets. Divide both sides by 2, gives you 12.5. And bring the 4 over, gives you 12.5 minus 4 is 8.5, which is, of course, the answer we already had. So one of these two methods works for you. This either makes sense to you or it doesn't. The other method, where you wrote out the list of steps and then systematically undid them, maybe that works for you. It doesn't matter which one you choose. You just need to be able to have some sort of framework that you can walk through in order to help you undo steps for each algebra thing. So here's one of those weird fraction-y looking ones. So I'm going to switch it to negative exponent notation so you can see which parts of the argument and which parts are not. So the 3, the x, and the negative 8 are all in the denominator. So they are all in the argument of this particular function. And we're going to try and find when this function is worth negative 2. So we're going to solve that. All right, so list of steps. You start with the x. The first thing you do is subtract the 8. Once you subtract the 8, you multiply by 3. Once that's done, you need to execute the rational expression. Execute whatever to the negative 1. Once that's done, you multiply by 4. And once that's done, you add 2. And allegedly, that's going to give us -2 as an answer. Okay, so we just have to walk back through those steps. -2 plus 2, -2 subtract 2 if I undo that one, gives me -4. -4, undo this step would be divide by 4, which gives you -1. Bring this up here. I have to summon the anti-function for something to the -1. Okay? This function's a bit weird. The anti-function for something to the -1 is something to the -1. It's its own anti-function. So in order to undo this, I'm going to have to apply it to the other side. -1 to the -1 is 1 over -1, which is -1 is my answer. Bring it up here, -1, undo this, divide by 3, gives me -1/3. Bring that up here, -1/3 plus 8. Well, 8 is 24/3, which gives me 23/3 as my answer. Lovely. Now, to check it, we could run through this with all the fraction rules if you like, but I don't want to do that. We're just checking anyway. So I'm going to approximate that as 23 divided by 3 is 7.667. So I'm going to run this through these sequences of steps and see if I get -2 as an answer. So 7.667 subtract 8 gives me -0.333. Times 3 gives me -1. That thing to the exponent -1 is -1. Times 4 is -4. Plus 2 is -2. So it works. So you've got this process then for how to get through solving any function you like. As long as you can write the steps out where you evaluate the argument first, then execute the function, then apply the external stuff, and then systematically undo all those steps in the correct order. So far we've used some anti-function and function pairs, and I'm just going to write them down so that you can see which pairs go together. So if your function is x squared, the thing you need to break that is plus or minus square root. Now that's a bit of a weird one because you need the plus or minus on that. If you have a radical, you break that with squaring. Notice that the plus or minus is not necessary on this particular step. If you have e to the x, that is broken with ln x, and vice versa. E to the whatever. If you have 1 over x, that is broken with 1 over whatever. This one is hard to write down. So let's use the negative exponent notation. X to the -1 is whatever to the -1, and vice versa, obviously, because those are the same thing. So far I have 1, 2, 3, 4, 5, 6, 7 functions. All right, 1, 2, 3, 4, 5. 5 of my base functions, so that leaves 2 left, the sine and the cos. Now you should have been working on the sine and the cos in the independent study and realize that the anti-function for sine is this thing, and the anti-function for cos is this thing, and this is named arc sine and this is named arc cos. So when you come across these functions in your steps and you're trying to undo them, there's your list of anti-functions in order to get it done. So here we are on to the exponentials then, trying to use algebra to solve for a particular y value. So I have my function up here. It's been named d as a function of x. And I want to know when this particular thing is worth 10. So I'm going to have to put the 10 here, and I'm going to have to think about bedmas and such to decide how to undo this function. So first step, take my 10, pop it in there. Now, if I knew x, so I'm going to go through this like if I knew x, make a list of steps, and then we're going to use algebra to systematically eliminate them. So if I knew x, the first thing I would have to do would be to add 4 to it. Once I added 4, I'd have to divide by 5. Once I divided by 5, I would have to do 3 to this exponent. I have to actually apply the function. Once I had that, I would have to double it. And once all that work was done, I'd have to subtract 8. So if I do all this stuff, I end up with 10 as my answer. So that's what this line says. Take some number, add 4, divide it by 5, put that in the exponent on a 3, double your answer from that, subtract 8, you'll have 10. So if you sort of go through and logic your way through this, I did this last. How would I undo this subtracting 8? Well, you undo subtracting by adding. So if I hadn't done this, this would be 8 more. So if I do that, add 8 to this, I get 18. And this piece has successfully been undone. So I look at the next thing here. I had a multiplication by 2, so I have to undo a multiplication by 2, and you do that by dividing by 2. So when I double it, I have 18. If I didn't double it, I'd only have 9, because 18 divided by 2 is 9. All right, check. Now, at this line, I have to undo putting a number into the exponent on an x. Now, you can do this with logarithms. If you have a base 3 log button, you can just apply log base 3 to 9, and it will spit out an answer for you. If you don't have that, we're going to have to think about how we can undo this. So first off, I want you to look at the number 3, and I want you to look at the number 9. It so happens that 9 is 3 squared. I'm just going to write that down for you here. So if 3 to all this garbage is the same as 3 squared, then all this garbage must be worth 2. If you think about that, that's logically sound. So because this is true, this must be true as well. Now, all you had to do to get from here to here was recognize that 9 could be written as 3 squared. I changed the base. So as long as you can do that, you can kind of get away with this trick. I'm going to finish the question, I'm going to get an answer, and then I'll go back and I'll show you the log base 3 way. So if 2 equals this, check, that's undone. I have to undo a division by 5 now. You undo dividing by multiplying. So if I hadn't taken 1/5 of this, I would have 5 times as much. 5 times 2 is 10. Check. And if I hadn't added 4, I'd only have 6, because 10 minus 4 is 6. So this particular exponential function returns a y value of 10 at an x value of 6. Now, if I get rid of this little line here to show you the logarithm thing. The function way that you break an exponential base 3 is applying a logarithm base 3 to the other side. So if you happen to have a calculator that can do this, if you type in log base 3 of 9, it spits out 2 as your answer. Now, I think that makes more sense because it's just like all the other questions. Every function has an antifunction. So if you know these two are pairs together, you can just throw that on the other side and let the machine do the thinking for the calculation there. And it's not going to change our final answer because I still need to multiply by 5, which gives me 10, leaving x plus 4 behind, and I still have to take the 4 away. So I still end up with x equals 6. So I have a different flavored exponential now. I have a base 2 instead of a base 3. But I'm still just solving, so I just need to put this number into here and then make my list of algebra steps and then systematically undo them. So putting my 25 in, end up with 25 is 5 times 2 to the exponent, negative 1/3 x minus 6 minus 15. So if I look at this expression here, I find my x. The first thing I had to do to it was subtract 6. Once I subtracted 6, I had to divide it by negative 3. Once I divided it by negative 3, I had to put my answer as an exponent on a 2. So it's 2 to the something. Once I do that, I multiply by 5. And once I do that, I subtract 15. And after all that work, whatever number it was I put in there, after all these steps, the function spits out 25 as your answer. So I'm going to have to go back through this list and systematically dismantle it. So last thing I did was to subtract 15, so I need to undo this first. Undo subtracting by adding. 25 plus 15 would give me 50. No, it doesn't. It gives me 40. And all this stuff is still kicking around. So check, that's taken care of. Now I multiply by 5, so I have to undo that. So I undo it by dividing by 5. 40 divided by 5 is 8. Check, that's done. Now I have to undo putting a number on a 2 as an exponent. So I'm going to skip straight to the logarithm technique. The way you break an exponential is by using a logarithm of the same base. And then because this exponential is broken, only the argument remains, just like all those other functions we were working on. Now this here, if you have a log base 2 button, you can just use log base 2 of 8 and it will spit out an answer for you. If not, you're going to have to think about what exponent would you put on a 2 to get an 8. So let me rephrase that. If I had a 2 and I put an exponent on it and it gave me 8, what does this thing have to be? Well, it's not 1 because 2 to the 1 is 2. 2 squared is 4. That's not enough. 4 times 2 is 8. That's the right number, and it was 3 as my exponent. 2 cubed is 8. So because 2 cubed is 8, log base 2 of 8 is 3. That's, even when I say it out loud, and I most of the time know what I'm doing, it still sounds kind of messy. when you look at it here, this was the question, right? Log 2 of 8, and the answer was 3. And the answer is 3 because 2 cubed is 8. That's how those numbers relate to each other. So 2 to this exponent gives you that number. That's better. What are we doing? Getting rid of a 2 to the x. Done. Next step to undo is this division by -3. So you undo dividing by multiplying. 3 times -3 is -9. You give me x minus 6. Check. And you undo subtracting 6 by adding 6. So -9 plus 6 would be -3. So this function returns a value of 25 as a y value when x is -3. All right, so this is the last exponential we're going to solve in these videos. It's now base 10. I did promise you we would stick to base 2, base 3, and base 10. This one we're actually going to be able to use the log button on your calculator, so exciting. But to start, it's like every other one. I have a value for the y, in it goes, and then make my list and systematically dismantle the thing. So 38 is 1/2 of 10 to some exponent minus 12. So find my x. First thing I did to it was add 3. Then I divided it by 4. Then I put it as an exponent on a 10. Then I divided it by 2. Then I subtracted 12. And after all that, I ended up with 38 as my answer. So I'm going to have to undo subtracting 12. You undo subtracting by adding. 38 by 12 would be 50. So check, that's done. I have to undo this division by 2. You undo dividing by multiplying. So 2 times 50 is 100. Check. So here we are at the part you've all been waiting for. Now we get to undo this exponentiation on the number 10. So if I have to break an exponential, I have to use a logarithm. So I'm going to need a log over here. And when it's log base 10, you don't have to write the 10. That's just a weird math grammar thing. If you don't see a number, it's assumed to be base 10. Pop that in. Now that I've applied the logarithm on the other side, it is undone over here. So I don't need to write the 10 anymore. So check. Technically, we're done. Now grab your calculator, type in the number 100 and hit log. And if you do that, your calculator will spit out the number 2. And if you ask yourself, why is it spitting out the number 2? Because remember, this is base 10, and 10 squared is 100. Now, you maybe could have done that one in your own brain. But if this had been something uglier, like 36, you wouldn't actually be able to work out the number exactly. So it's handy to have base 10 things because you actually have a button on your calculator that makes it work. So finish off here. I need to undo dividing by 4. It means multiplying by 4. 2 times 4 is 8. And I need to check. Undo adding 3, you do that by subtracting. 8 subtract 3 would be 5. So this particular function returns 38 as a y value when x is 5. Okay, we've got our first logarithm to solve here. And again, logarithm is not technically part of this curriculum. It is part of the grade 12 course, but if you can do algebra on exponentials, parabolas, rational functions, radical functions, then you can do algebra on these. And I think it's important for you to see that the same rules apply no matter what function this is, because in a hot minute, we're going to start using sines and cosines here, which might look a little dirty to you. But if you can handle a logarithm, you can handle a trig function. So I've got my y value. I just need to park it in there. Switch colors because we have been working in all yellow so far. So 9 is 6 log of 5x plus 4 minus 3. So like all algebra problems, I find the x. And the first thing I would have to do to that x, if I knew it as a number, would be to add 4. Then I would have to multiply it by 5. Then I would have to apply log base 10. Remember that when there's no subscript, it's implied that it's log base 10. I'll just pop that in there for you. Once you applied the logarithm, you'd have to multiply by 6. Then you would have to subtract 3. And whatever that number is, if you did all those things to it, you would end up with 9 as your final answer. So walking backwards, I need to undo negative 3. You do that by adding. So 9 plus 3 would be 12. Check. You break multiplication with division, so I'm going to need to do 12 divided by 6, which gives me 2. Check. Now we've gotten to this log here. How do you break a base 10 log? Well, remember that logs and exponentials are a function-antifunction pair. So if you have a base 10 log and you need to get rid of it, you do that with a base 10 exponential. So instead of log on this side, it's 10 squared on that side. So technically this has been resolved. 10 squared is 100, so you can just put that in there. I need to undo that multiplication by 5. You do that with division. 100 divided by 5 is 20. Check. And I need to get rid of adding 4 by subtracting 4. 20 minus 4 is 16. So this logarithm has a y value of 9 when x is 16. Okay, so we have a non-base 10 logarithm. This one's base 2. It's not going to change much until we get to that section where we have to break the logarithm. I'll have to think about it then. But for now, I have a y value, in it goes. So 17 is 3 log base 2 of 8 times x minus 7 plus 5. All right, so find your x. It's right there. If you were following order of operations, the first thing you'd have to do would be subtract 7. Then once you had an answer, you'd multiply it by 8. Then you would apply log base 2, however one does that. Once you had that answer, you'd have to multiply by 3. And then you'd have to add 5. And whatever number you put in there, if you ran all those steps, it says you're spitting out 17 is your answer. So what number did I put in there? Well, I break a plus 5 by subtracting 5. So 17 minus 5 is 12. Done. And you break a multiplication by 3 by dividing by 3. So 12 divided by 3 gives you 4. Check. Now I've gotten to the part where I have to break this logarithm. So when it was log base 10, I used 10 to the x. If it's log base 2, I'm going to use 2 to the x. So to break this log base 2, I'm going to need 2 to the exponent 4. So you might want to rewind that back and watch it again. You see the base? Put that number as an exponent on that base, and you've broken your logarithm. Check. 2 to the power 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4 is 16. I have to break this multiplication by 8. So 16 divided by 8 gives you 2. Check. And I break subtraction by 7 by adding 7. So 2 plus 7 is 9. So this logarithm here has a y value of 17 when x is 9. Okay, last logarithm for us to go through. We've got a base 3. So carry on, I guess. There's my y value. It needs to go in for k of x. And if you find your x there, order of operations says add 10, then multiply by 9. Apply a log base 3, however you do that. Multiply by -4, and then subtract 8. And whatever number I put in there, if I let all those steps work on it, I'm allegedly getting -28 as my solution. So, working backwards, break a -8 by adding. -28 plus 8 gives me -20. Oop, got rid of that, so I don't need to write it down again. Check. The break multiplying with division. So -20 divided by -4 gives me +5. Check. So I'm at this stage. When this was base 10, I would have written 10 to the 5. If this was base 2, I would have written 2 to the 5. Because it's base 3, I need to write 3 to the 5. All right, now we're going to have to let my overheated brain work on that. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So 3 to the exponent 5 is 243. Check. All right. Need to break this multiplication by 9, so I'm going to have to divide this by 9. So 243 divided by 9. If you get your calculator out and you work that out, I believe the answer is 27. Check. And to finish, I just have to subtract 10. 27 minus 10 is 17. Okay. So this particular logarithm has a y value of -28 when the x is 17.